try question one, guys, please. It's not a difficult problem, guys. You guys do question one, please. Question sheet 7. You will get to sheet 6 later on next week or the week after. So this week is sheet 7, guys. Right? Alright guys, let me show you how to do the question one is to show that all right, is to show that this is equal to this plus this. So you can either start from the left hand side and show that it's equal to the right hand side, or you can start from the right hand side and show that it's equal to the left hand side. Okay guys, so now it's up to you to decide. But if I were you, if I were you, I would start from the left hand side. The reason why will become clear in a minute, right? Because right, this is the left hand side, guys. Now I want to show that this is the same as the right hand side. Okay, now if you look at the right hand side, guys, you have an x bar here and an x bar here, guys, right? So the first thing I want to do guys, is to write this as this. You see what I've done? Oh, why I have done this? Because you have x bar on the right hand side, and because of that I have introduced a minus x bar and a plus x bar. So I haven't changed anything, guys, right? Right, now the next thing I want to do, guys, is to put brackets around these two terms, these two and these two. Now if you complete the squares, you have one term plus another term squared, all right? If you expand the brackets here, guys, you get three terms, right? The first term will be, this is the first term. The second term is this one, and the third term is this. Yeah, so you have three terms, because when you expand a plus b squared, you have a squared, b squared, and 2ab. So that's why you have these three terms. Yeah. Now the next step, I'm gonna take the sum inside the square brackets. So you get three different sums. You get three different sums, guys. Now the next step is, I'm going to ask you what can you say about this sum here, guys? This, what you're summing here, is a constant, because x bar minus mu squared has no I in it. The sum is over I from 1 to n. You're summing a constant from I equal to 1 to n. So what would you get, guys? If you sum a constant from 1 to n, it's n times the constant. Yeah, I'm sure you know this, guys. I mean, just you get n times the constant, which in this case is this, right? Next thing, trying to find my pen here, guys. I don't know where it is. All right, the next thing I'm going to do is the 2 here and the x bar minus mu here are constants, so you can take them outside the summation sign. So if you pull them outside the summation sign, you get 2 x bar minus mu times the sum of this. You see what I've done? I have pulled out the constant. 2 is a constant, so is this one. So you can pull them outside the summation sign to give you this, guys. Right? Yes? Alright, the next step, we are nearly there, guys, so don't worry. Only a couple of steps left. The next step is I'm going to take the sum here inside the brackets. You see, you have a bracket with xi minus x bar. So I'm going to take the sum inside, so it will become the sum of xi, I from 1 to n, minus the sum of x bar, I from 1 to n. Yeah? You with me? All right. This is the last step. Now what you have here, the sum of xi, guys, the sum of xi is equal to, by definition of x bar, is equal to nx bar. And the sum of x bar is a constant with respect to I. So if you sum it from 1 to n, you get also n times x bar. So this term here is equal to 0. So what we have shown is that this is equal to the right hand side. So we have proved the result that the left hand side is equal to the right hand side. Is this clear to you or no? You're also, yeah, good. Anybody not clear, guys? Yeah. I put this in the scan, online, so you don't need to copy. Yeah. All right. Are you guys okay? Anybody not clear, guys, or no? All right. The next question is question 2, but question 2. You should remember, I did this question in a lecture. I think it was last week. I did this question in the lecture last week. Question 2. You guys remember or no? I thought you have a better memory, guys. Do you remember I doing this question in the lecture last week? No? Yes? Anyway, look in the scan notes, guys. You will see I did question 2 in the lecture last week. Yeah? And question 3, unless you want to be, it's not an easy question, guys. Maybe some of you are really smarter than me, I guess. You can try to do it, but I mean, question 3 is really hard. It's not easy to do. So, all right. But if you want to try it in your own time, please do so. All right. So can you now do question 4, guys? Can you do question 4, guys, now? All right. Can you guys do question? If this is okay, can you do question 4? If this is not okay, ask me now. You can ask. Feel free to ask me. Sorry. You sound this You okay? Are you alright? To do question 4, guys, you need to use equation 72 in the lecture notes, guys. If you look at the lecture notes on page 16, 16, equation 72, you need to use that equation to do question 4. And also question 5, same. Alright guys, let's see how we can do this, guys. You're told, you should read the question, guys. Oh man. It says there are, oh, I need my glasses for this one. Sorry. It says there are 20 observations, so the sample size n is equal to 20. Right? It also says that the observations are from a normal distribution with mean mu and variance, which is sigma squared, equal to 1.4. Right? The question is to find A and B. So you want to find A and B such that the probability that S squared, remember, is the sample variance, between them is equal to 0.95. Yeah, this is the question. Now, the first thing, do you guys remember the definition? Do you guys remember the definition of sample variance? How do you define sample variance? I think I mentioned in the class. Then you guys remember the definition of sample variance is this. Come on, guys. I thought I mentioned this in the class. All right. This is the definition of sample variance. Yeah. All right. The next thing I'm going to do is I'm going to multiply each of these numbers by n minus 1. So you get n minus 1 times A less than okay. And the next thing I'm going to do, you see why I'm doing this in a minute. The next thing I'm going to do is I'm going to divide each of these terms by sigma squared. And you see in a minute why I'm doing this, because I want to use a particular yeah. Now, let me ask you now, what distribution will this have and why? This is where the hint I gave you guys. What do you know about this, guys? It has the chi-square distribution with n minus 1 degree of freedom. Right? So that's because of equation 72. You should look at equation 72 in the lecture notes. You will see that this guy has the chi-square distribution with n minus 1 degree of freedom. Right. Okay. Now, I'm going to draw a plot here, guys. Just bear with me. Typically, the shape of a chi-squared density function looks something like this. This is the typical shape of the PDF or the density function of the chi-square distribution. Now what we are looking at, 2 points, this point and this point, so that the area between them is equal to 95%. So we are looking for a point over here and a point over here, so that the area between these 2 points, that is this area here, this area here is 95% of the total area, right? So if this area is 95%, then this area and this area make up 5%, all right? Okay, guys. So for example, this could be 2% and this could be 3%, or this could be 3% and this could be 2%, and so on. But to be fair, let me take this to be 2.5%, right? And let me take this to be also 2.5%, right? So the total area under the curve is 100%, as you should do, right? Now, if this is 2.5%, guys, what can you say about this point here? This is the percentile of the chi-square distribution that has an area of 97.5 above it, and this point here is the percentile of the chi-square distribution with an area of 0.025 or 2.5% above it, which is this area. All right, so what we are saying is that this guy here must be equal to this, right? And similarly, this guy here must be equal to this. Yeah. Do you guys follow what I'm saying? Because we are looking for 2 points. That is this one and this one. So the area between them is 95%, right? This must be equal to that, and this point here must be equal to that, right? So in other words, what I have said is the following, that n minus 1 times a divided by sigma squared is equal to this, right? And n minus 1 times b divided by sigma squared is equal to this, right? Now, from these 2 equations, you can solve for a and b, because you know the value for n is equal to 20, and you know the value for sigma squared, which is 1.4, and you can read these from the tables. In the exam, you will get the tables for the chi-square distribution, and you can use them to get the value for this and the value for this. So once you know all the values, you can solve this equation for A and solve this equation for B. That's it. Is that, you guys okay? Oh no. Is that not clear or not? Are you guys okay or not? All right, sir? Yeah, but you don't need to assume, because you could choose any other percentage, but for fairness, I chose it to be 2.5 and 2.5 on either side. But you could also choose it to be 1 and 4 or 4 and 1. So yeah. Well, in that case, the answer would be different, but but here, just for equality, I chose it to be 2.5. Yeah. Alright guys, if this is okay, can you do the next question guys, question 5.
It's because it's the area to the right hand, you know, the area to this to the right hand side is 0.97.5 or 0.975. Yeah. No. It's always I always look for the area to the right hand side. Yeah. 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 No. I always choose the direction. I always choose this direction, not this direction. In my notation, I use 0.1.5. This will be 0.95. So it will be this point here. If this is 0.05, this is 0.05. This point here will be the Z 0.05, and this point here will be Z 0.995. That's the notation I have used. I know it's different from the other courses you have taken, but this is the notation I use in my course. Yeah.
Not this.
No.
But this is
Jennifer, you say what you said? Jennifer, so in that case, it would be 24 years. Yeah. How you said? You okay? Is that this is clear to you? Or? I guess okay here. Can you do question 5, guys, please?
all the
On the right. Oh, right hand side.
So question 5, you also need to use the same result, that is equation 72, to do question 5 guys.
Okay, fine. Question 5 is just the area. This, okay, let me show you. This notation here, it means, like if you draw the PDF or the density function like this, right? And this area here, suppose this area is equal to alpha, okay? Then you find the point over here is equal to whatever it is point here. If this area is alpha, then this is equal to this point here. That's what it means. If this area is alpha, then this is equal to this. It's the same for any distribution, not just chi-square. It's also the same for f, t, normal, r-square, any distribution, any distribution. Are you guys okay?
This is
Alright guys, let's see how we can do question 5 guys. Um, this is question 5, okay? All right. Now we are told that 16 runs, so the sample size n is equal to 16, and 2.2 is the sample standard deviation, which is 2.2. Remember, s is the square root of s squared, and we are trying to test the hypothesis that sigma is equal to 4.5. All right, so this is what is given to us. You're told that n equal to 16, s equal to 2.2, and we are trying to test the hypothesis that sigma is equal to 4.5. Now, if you look at equation 72, right, which says which says that this must have a chi-square distribution with n minus 1 degree of freedom. Now, let me ask you guys. Now, this here is equal to what? This here is equal to n minus 1 times s squared. Can you see that? Because by the definition of s squared, this is equal to n minus 1 times s squared. Yeah. Now, n we know is 16 minus 1. S we know is 2.2. And sigma we know is 4.5. Right? And this must have a chi-square distribution with this number, right? Must, if the null hypothesis is true, that is, in other words, if sigma is equal to 4.5, this must have a chi-square distribution with 15 degree of freedom, or degrees of freedom. Okay, is that clear, guys? Yeah. Now, how do you check that a number, what you have here, guys, is a number, it's a single number. You can work this out in a minute, right? You want to check whether this number follows the chi-square distribution with 15 degrees of freedom. Now, how do we do that? That's the question. Now, to answer that question, okay, let me show you a plot. All right, this is once again the PDF of a chi-square distribution with 15 degree of freedom. Typically, it will look something like this. Suppose I cut off the top 2.5% and the bottom 2.5%. So this is the top 2.5%, and this is the bottom 2.5%. Right? Now, if you cut off these two, the area between this point and this point is 95%. Right? The area between this point and this is 95% of the total area. All right. Now let me explain what's going to happen. Now, if this value, I mean, this is a single number, all right? If this value follows the chi-square distribution with 15 degrees of freedom, then you would expect it to fall in the central part of the distribution. I mean, if a number follows a certain distribution, you would expect it to fall in the central part. When I say central part, I mean somewhere here, or here, or here, or here, or here, or here, right? You would expect it to fall in the central part of the distribution, not in the extreme left or the extreme right. You wouldn't expect a number that follows a certain distribution to fall in this area or in this area, right? Okay. So if it so to answer the question that whether that number follows the distribution, chi-square distribution, what you need to say is that it must fall in the central part of the chi-square distribution, that which is this area here. From the area from the interval from this point to this point, right? So the answer you will give is the following: that accept the hypothesis that sigma equal to 4.5 if, right, if this number, which is 16 minus 1 times 2.2 squared divided by 4.5 squared, all right, lies between this point and this point. In other words, this point is chi-squared 15 with 0.975 above it, and this point, this is this point here, and this point here is chi-squared 15 with 0.025. Alright guys, so that's the answer to the question. So we will accept the hypothesis that sigma is in fact equal to 4.5 if it falls, if the number, if this number falls in the central part of the distribution. Right? Is that clear or not? Are you okay, man? You got that? You got that? Yeah. Any distribution is normally 95% or 95% of the interval that gives the 95% area. Yeah. You guys okay with this or not? How are you, sir? You alright? Yes, sir.
Did you just assume this one is 5%?
Yeah, I assume, sorry sir, I assume this is 2.5%. So that's what, this or this. So it's basically the same as what I have written. It's the same as what I have written.
Did you assume it's
Yeah, 5%. Yeah. 5% when you divide by 2, so it becomes 0.025. Yeah. So it's the same. What I have written here is the same as this.
Yeah.
Yeah. Okay. Yeah. You know, sir? Let me guys do question 6. We only have to couple of minutes. Yeah, I think it would be good if we evenly split. Then you could argue that this is a separate part. I mean, yeah, rather, yeah. I think it's good to have it evenly split. Yeah. All right, I would just got a couple of minutes left. I would just do the first part of before you leave, guys. Let me do just first part of question 6. So this is question 6, guys. Just give me a sec, guys. Question 6, part 1. All right, you are told that X follows an F distribution with parameters A and B, which implies that X by equation 80, if you look at equation 82 of the lecture notes, you will see that an f variable can be represented by this equation 82. Now you should take 1 divided by x, then it's 1 divided by this, which can be written as this. And once again, by using equation 82, what you have here is also a ratio of chi-squared variables, and therefore it must be an f variable with parameters b and a. It's by equation 82 once again. Alright, so we have proved the result that if x follows the f distribution, 1 over x follows also the f distribution, but with the degrees of freedom switched around. Is that clear or not? Just using one of the equations in the notes, guys, which is equation 82. If you have the notes with you, you can see what it is. Alright? Right, and the second part of the same question, can you try that by yourself, guys, because I run out of time for today. So you can see the solution online for the second part of this question. Okay. All right, guys. The exponential shape, there's only one here. Okay. Can you pass this on? Thank you. Has everybody signed the exponential, guys? Okay, you have.
How
Hi
do you?
Martin. All right. Fine, thanks you.
I'll do.
Sorry.
I'll do. What's going on?